Now let's look at the second example problem in this topic. It's called the sleuth. So let's show the problem. So if you haven't read the problem, you should pause the video, read the problem carefully to understand what it is. So assuming that you've read the problem and I should have understood it, in essence, what the problem asks us to do is, given the input question, we want to return yes if the last character is a vowel and no otherwise. So let's look at some of the samples. So for example, here the first one, the answer is no because the last letter is N. So that's not a vowel, so we should return no. And this one we should return yes because E is a vowel. This one we should return yes because A is a vowel. So note that we can't just say we know the last character is a question mark and just look at the character before it because there could be a white space here. And here Y is considered a vowel. So the answer is yes here. So we need to be able to handle both lowercase and uppercase. So that's this problem. Now, the way to solve to write programs is to break it down into individual steps that you know what to do. So I guess there are a couple, well, at least there's two things that we need to do. The first one is we need to find the last character that is a letter. And the second thing is we need to check whether that letter is a vowel or not. So it's one of A, E, I, O, U, Y. So how do we find the last letter? So then one way to do it is we starting at the very end of the string, and then we just keep going forward and until we find something that is a letter. So then this means that we need to be able to start at the end and then going forwards, and we need to use a loop in some form. And then we need to tell whether a character is a letter or not. Um, so we need to be able to solve all these individual pieces. Then we can put them together and solve this problem. So next, I'm going to show the one version of the source code. I encourage you to start try write the code yourself. Of course, if you don't know some of the ways to do this, then just keep on watching. So this is version 1 of the code. So roughly what it does is this loop will start from the last character and then keep going forward. We're going to explain this in a little bit more detail later. And then for every such character, we will check whether it's a letter. So this function checks that. And if it is a letter, then that letter determines what we are going to do. If it is a vowel, we will print yes. If it is not a vowel, we will print no. No matter after we print one of these, we're going to break because there's no point in looking further. The last character that is a letter will determine everything. So now we're going to examine the individual steps to explain how why the code does what we want it to do. So the first thing is we want to look at one character at a time. And we use this syntax, which is very similar to a list syntax, accessing one element of a list. So you can think of a string as a list of characters, and every character have an index. And SI just gives one character at the index I of this string. So when I goes from the back forward, so we're looking at each character. And in Python, one character is simply a string of length 1. So most other languages have a different type for character compared to string, because character is one character and string is multiple. And Python has no such distinction, so there's no separate data type. So character is simply a string of length 1. So I guess this has some conveniences, as we are going to see for some of the things we want to do, because we can use string functions for doing that. So this code uses this function is alpha. So that's one of the methods that go with the Python strings. So here, using two slides, we're going to list some of them. And there are others. So I think I've listed the most useful ones, but there are other methods that I didn't list. And you can always just Google Python string method to find out more of them. So we use this is alpha, which return true if all the characters in the string are in the alphabet, meaning that they are letters, so A through Z. It could be either lowercase or uppercase. And its digit will return true if all characters in the string are digits, so that means between 0 and 9. And is this stands for is alphabetical or numerical. It will return true if all the characters in the string are either letters or digits. And is identifier will return true if the string satisfies the syntactic rule for identifier. So that means it starts with either the underscore or a letter and followed by 0 or more letters, digits, or the underscore character. And its lower return true if all the letters in the string are lowercase. Its upper return true if all the characters in the string are uppercase. So I guess a question is if I have say digits and other things in here, what will be the what should be returned? So let's actually check that. I actually don't know for sure. So let's do print A123 dot is lower. True. Okay. So I guess what matters is the letters. So if it has other things, then that's okay. So all the letters in the string are lowercase. So that's what this function mean. And similarly, is upper is all the letters that are in the string are uppercase. So then these slides has more functions. So lower will actually convert the string into lowercase. So this will return a new string that have all the letters are converted into lowercase. And split will split the string using the specified separator, and by default, the separated white space. So we've used this to parse input where one line contains multiple numbers separated by white space. We use split. This will cut off this one string into multiple pieces, and then we can convert each one of them into an integer. So start with will return true if the string starts with a specified value. So you need to pass in some value for this function. And strip will return a trimmed version of the string, meaning that if the string have a white space at the beginning or the end, we will remove all of those. So the return string may be shorter, but it will not start with the white space and it will not end with white space. All of those white spaces are removed. Upper will convert the string into uppercase, and the count will return the number of times the specified value occurs in a string. So the value would be a string, so it could be a character, a string of length 1, or a longer string. It will check how many times that string appears in this string. So let's actually try that. So I guess what I'm curious is if I have a 11112 and I count, or let's make them AAAB. If I want to count how many times AA appears, so it counts as 2. So that behavior is okay. So I guess the first one would be considered to be here, and the second one will be here. Let me put another A here. Okay, so it's still 2. So the matching will not be overlapping. So I guess the logic is you start into the string and you find something that exactly matches this, and then that is gone. So then you start at after that is gone, that appear once, and then you try to see whether you can find another match. So if I add another A here, The answer should be 3. Yes. So that's the logic of this count. Because you could argue that AA appears, I guess, 5 times here. Because I have 6 continuous A, there are literally 5 places where I can start and find 2A, but they will overlap. So this count does not consider that. And ends with will return true if a string ends with a specified value. Find will search the string for a specified value and return the position of where it was found. So I guess if I do this, do find, it should return, I think it should return 1 because 0 is the first index of the first guy, but that's C. And yes, so this finds 1. So this finds the first occurrence of this string, of this thing I'm trying to find in the string. Okay.